Hello, everyone. My name is Leon Fan. My pronouns are he and him, and I'm a third-year CS major at UCSB. The reason why I want to apply for a ULA position is because I used to have a hard time studying data structure myself, especially at the beginning of COVID, and I was helped by many ULAs. And later on, I became very interested with data structure. I personally did many problems on them. And now I want to become a part of the team to help more students who are just like me. And the top courses I would like to tutor for are CS24 or CS32. So today for my ULA demo, I want to introduce the concept of binary tree. The reason why I picked this topic is because I think binary search tree is a very, very important topic for students to understand because it's one of the most fundamental and basic data structure. And it also comes up a lot in many technical interviews as well. So first of all, we have to ask ourselves a question. So what exactly is a binary search tree? And just like many other data structures we have learned from previous CS classes, binary search tree just another data structure for storing and organizing data. But however, it is very different from some of the other data structures such as array and linked list is because for array, we have to loop through the entire array to look for a specific item. And in doing so, the running time will be big O of n. But for data structure, for binary search tree, we don't have to do that because due to its unique property, we don't actually have to loop through the entire structure in order to look for a specific element, and therefore making binary search tree a lot more efficient than array or linked list. So let's talk more about binary search tree. Binary search tree is comprised of smaller entities commonly known as tree nodes. And we can store many different forms of data in tree nodes. And for the simplicity of this tutorial, we'll just be using integers. And in this visual representation, the circular objects are tree nodes. So 6 is a tree node, and 9 is a tree node, and 7 is also a tree node, and etc. And the arrows represents the edges, which are the connections between different tree nodes. And we know the edges are going down in this case. So we can say 6 connects to 3, and then we can traverse from 6 to 3, and then we can traverse from 3 to 1. We can also traverse from 3 to 5. But as we know, these edges are not bidirectional, which means we cannot go from 5 to 3. We can also not going from, let's say, 9 to 6. So let's talk more about tree nodes. So here we have 6, which is at the very top of this binary search tree. And therefore, we call it the root node of this binary search tree. And all the other nodes are the descendant of the root node. So the node to the left of a node is its left child, and the node to the right is its right child, which I think are very intuitive to understand. So we can say in this case, 3 is a left child of 6, and 9 is a right child of 6. And the nodes at the bottom that have no children in this case are 1, 5, 7, and 11. As we can see, there are no nodes after them and there are no edges coming out of them. So we know because they don't have any children, we call them leaf nodes. Now I'll go over some of the key properties of binary search tree. So the first rule is that all the values in the left subtree of a node is lesser than the key of that node. And in this picture, I think it's very clear that let's take 6, for example, here. So the left subtree of 6 have 1, 3, and 5. And all these values are smaller than 6. And for the second rule, we have all the values in the right subtree of a node are greater than the key of that node. And it's also very intuitive because we know here is the right subtree of 6, and all the values in this right subtree, 7, 9, and 11, all greater than 6. And the third rule is that left and right subtree each must also be a binary search tree. So why is that? Here we can see this is left subtree of 6, and 3 is the root. And we know 1 is the left child, which is smaller than 3. 5 is bigger than 3, and 5 is the right child. So it fits all the properties I mentioned before. So the left subtree is also a binary search tree, and the similar rules can be applied to the right side. So the right side here, this is also a binary search tree. So therefore, we have rule 3. And the last rule is that no duplicates are allowed in a binary search tree. And as we can see, there are no repeated values in the subtree. Thanks for listening. And we talk about more about binary search tree in the future. Thank you.